Hello everyone, welcome to Noble Creative Tutorials. Today we have a new motion graphics tutorial in our series, and I will show you how to graph polar and parametric equations in Adobe After Effects using expressions. So create your composition and let's get started. So as you see in my comp here, we have these very simple animation for polar grid, very straightforward to create. So you can see here we just use these shape layer, just very straightforward animations here. So we're not going to cover these in this tutorial. And here we got these polar equation and parametric equation here that we're going to see how we can graph these in After Effects using expressions on solid layer and on a shape layer as well. So let's create here and use solid. Let's rename these polar, and then we're going to use right on. We have covered before how to draw a sine and cosine equations using right on, and so now we're going to see how we can use it to draw or graph these polar and parametric equations. So as you can see here, it got just on top of everything. So pen style is going to be on transparent, so we can see everything here. And you can see we have brush size. Let's put there 5 so we can see this little dot right here. And here we have this position, so you can see how we're moving that right there. So let's create keyframe and then just move this so you can see what's going on here. So you can see this drawing here, and it's actually just right on as we're going on time right there. And so we're going to use this for graphing the expressions or graphing the equations. So everything else here is hardness, very straightforward, opacity, and length. And here we have spacing, which is very important. We're going to see what that is doing. So let's create here expression. And so the first thing is we need our equation here. So the equation is R equal A multiply by cosine. So in After Effects, we're going to use math period cosine here. And we're going to multiply that by, of course, theta. So we're going to figure out how to get that theta here. And we need actually variables. So right here, let's get angle control, and this is going to be the angle control. So basically, let's just leave here angle. And I'm going to use slider control here. So this is going to be A, and control this, and another one is going to be size. So right here we're going to add these variables here. So let's start with I equal angle and A equal A here, and we have N, and we have the size. Okay, so now we have these variables. So the next step we're going to do is to create angle equal I dividing that by 360, multiply by time, and multiply by 360 again. So we're going to use time so that angle let's keep going. And then we are going to basically, here is the trick. We need to have these R equation. We got everything else but theta. So the theta here is going to be 2 multiplied by math period pi. And we're going to use time inside the math cosine as well. So right here we have R right there, and we can add size here inside or multiply by the whole thing. So this is just to change the size of the whole graph right here. Basically, in this case, A can change the size, but we want to keep the equation very clear right here. So now we need to create C equal a math period cosine here. And we're going to change here or to convert degrees to radian. So here is going to be the angle that we created right here. So make sure to select the angle, the second one here, and it's going to be S equal, this time is going to be math sine here. And so the same thing, we're going to just change these to radians as well. So here basically can be a little bit tricky, but you need to pay attention. This is going to be multiplied by R, and so let's do that. So because this is array, it needs X and Y. So we need X and Y to be able to draw these or let this animation going. So we're creating the data for that. So here X equal R multiplied by C, and Y equal R multiplied by S. So basically these values are going to be on radian here, okay? Because this R is in radian. So for now, what we need to do is center the brush position. So we're going to create a center variable here and equal. So this is going to be array, and we're going to use xcomp comma y comp. So let's back here and create these variables here. And this is going to be just basically values. So here let's just duplicate these. This is going to be xcomp, duplicate that, and this is going to be the y comp. So let's just assign these for these variables here. So the x comp and y comp basically is the center of our comp. So basically here is the width of the comp divided by 2, and this is the height divided by 2 as well. Okay, so now we have these assigned to the center here. So what we're going to do is use add center. So every time we're going to add these values here. So add and then semicolon here, and then open these brackets. So this is X and Y. So here, right now, you can't see anything because the dot and the values are all set to 0. So let's get here 180. Let's give these 2, and let's have these 3, and the size, let's have these 50. So now we can just make these a little bit bigger here. So you can see like a flower or rose curve right there. So on brush spacing, we're going to put this to the minimum so we can see something here. And let's change color of these to something right there. Okay, so as you can see here, we got so many petals, and basically here at the end, it should indicate how many leaves we need to have there. So let's first just to get a little bit of spacing so it's not going to slow down things right here. So to get the right amount of petals, we need to set the angle to 360. So now we have 3, we can have 5, and so on. So here it's depend of the number of n, if it's odd or even. So you can have 7 and so on. So just here need to render. So you can see here we got the number of petals we need, and if it's depend of the number is rational or irrational. So exactly it's graphing what these equation for. So for example, if we have 1 divided by 2, we are going to get a different looking as you can see here, and it's actually animating there. So let's just have divided by 3 and so on. So we got like all kind of these graphing from these expression or from these equation here. Okay, so another thing I want to show you here is that if you need the graphing start drawing not at 0, you can see here it start exactly at 0. So here let's create a variable or slider here. This is going to be big in time. Let's just copy these and we're just going to add these right here equal these, and so this is going to be 2 seconds, and right here we're going to use if. So let's just use these before the angle. So if time is less than big in time, so we want time to equal 0, else we want these time equal time minus the big in time. So I think we got something wrong here. Okay, so now we have that. Going to start at 2, we can have that starting at 3 seconds. So now it start animating there, but you got the dot right there. So if you want to get rid of these dots, you just need to apply these basically for opacity here. Okay, so let's add the expression right here. So basically what we're going to do here is using opacity equal 0 or opacity equal 100. Very straightforward. So now we don't have that and it's going to start animating. So let's preview and see how this looks like. Okay, so now I'm going to show you how to create the parametric equations here. So I'm going to copy that and then let's open these right here. So now we don't need these. And so all what we need here is x and y. So right here we have the equation x and y. So let's just keep these right, math cosine and the math sine here. And we need to create the variable q here equal, let's just duplicate these, Control D, and it's going to be q, and let's just add it right there. And so now we need, let's just copy these theta here, which is going to be this new angle here. So theta equal time, let's just remove these, time multiplied by math pi. So now we have these in radian and just put it inside there directly. We don't need to change degree to radian. So now we got it in. Let's have some variables there. Let's add basically size for these as well. Size, multiply that. Okay, so as you see here, we got these shape right here. Very interesting looking, as you can see here. So now let's say we want these to be 1 divided by 2, for example. And let's say n, we want that to be 3. And let's have these a little bit bigger here so you can see what's going on right there. So we got all the kind of shape using that right here. So you can play here with Q. So maybe two, for example, different shapes. Let's have that 3 so you can see what we got there. 4 and so on. So we got all kind of what you would expect from this equation. So very straightforward, as you can see here, using right-on effects. Another thing here, I want to show you very quickly here. We have all these graphs here. So as you can see here with these shapes right here, using the same technique, you can just create all these, just changing here your equation. So this butterfly, its equation right here, same for this heart, and everything else basically is the same. So I want to show you, for example, here, we got all these values that you can change and what you can expect from it. So here, all different shapes, and also we got so many other stuff like convex and lemniscate and curve. So also here, this rose curve, what you would expect, changing here the values right here very quickly. For example, going to divide that by 5 maybe, and let's see what we're going to get. A little bit slow because spacing is there, so we can see 1 divided by 5. We got the shape here. So very straightforward. So using right-on is just change your equation, and there you go. So now I'm going to show you how basically you can use a shape layer. So let's create a shape layer. Just make sure you need just stroke here, and let's just have these, and this is going to be polar, and then I'm going just to copy all these except right on and paste it here. We don't need these actually sliders here. Going to do the same thing here for this expression just for time. So show you quickly how to create that on shape layer. So we're going to paste these, and of course it's not going to work. So the first adjustment we need to do is let's change these to angle, and let's remove these. We don't need these F, and let's just remove these basically here. Let's just keep this one right here. Okay, so for now, what we're going to do here is basically we need to create a path variable as well. So this is the path itself, and first you need to know that path got vertices and each points got coordinate. So we need to have these values. So we need to create a data that is going to equal array. So this data is what is going to collect the values of x and y. So and now we're going to use for loop, and then we're going to use it as usual. I equal 0 semicolon, and I less or equal 2 pi. This time I'm going to use 2 multiplied by math pi, and semicolon I. We are now going to use increment by plus plus, but we're going to have a precise and control over how many points we want to have. So let's say like steps. So 1 divided by n. So this n is going to be steps, or how many vertices to have in our path. So now this is going to be 4, and we need the 4 to be inside here. So I multiply, we don't need time. So let's just I multiply by 2 math pi. And so this theta is going to be inside here, and we're going to use Q multiply that by theta, and here we have A, and size. So basically right here, we don't need this degree to radian. So we're going to change these to theta as well. Okay, so now we need x and y. So x equal r multiplied by c, and y is r multiplied by s. And so here we need to get the data. So data, we're going to use push. So we're going to push these x and y values at the end of the loop. So every time we're getting x and y. So here our loop is finished. So start it right there and basically finish right here. So now is the time to create the path. So we're going to use our variable, which is path, and then we're going to use path creates path here. So you can see these points right here. Just remove all these, and this is going to be the data. So that's what we need to call. You can see we have something right here. Let's just center these and let's make it a little bit bigger here. Okay, so we got something, as you can see here. And basically here, you can see we have steps set to 3. Let's have 50. So now you can see something going on right there. Let's center these again here. So on these, you can see we have this path is closed, so we're going to set that to false. And so we don't have these problems, so let's get rid of it right there. So you can see here we got our rose curve here. So right here, let's set that to 3. And you can see now, if we want that to be very smooth curve, let's set there 100. And there you go. So it's getting smoother. Let's put A to 2 so we have it a little bit big. So you get the idea here, the difference between using a solid layer and shape layer, you get a lot of control here. So now you can basically just use trim path right here and just trim this. So let's see how this is going to be very flexible using path properties or shape layer properties to create so many very cool stuff. So basically, to use angle here, you can just add it right here, 0 plus degree to radian, and use the angle here. So basically you can see that is set to 1. So if you can see now, you're having control over that. So let's move a little bit there just to update. You can see getting these control here if you need to. So you can just see what time you want to start or what degree this reading should start. So that's it. And basically here we got so many different ones using all basically the same on path here. So you can have all very cool stuff using path. So you can have all the control on path as you would expect. So that's it, guys. Hope you find this tutorial very useful for you as always. And if you have any questions, just comment and I will do my best to be responsive. And don't forget to like and subscribe for more tutorials coming soon. And thank you for watching.